Hello learners, in this video I am going to discuss about facts related to circle. Today you are familiar about that. First, circle. It is denoted by usually by C bracket star O comma R bracket close. As you know that the set of points which are at a constant distance of R units from fixed point O is called a circle with center O and radius R. Also, you know, circumference, also called as perimeter of a circle, the distance around the circle or length of the boundary or length of a circle is called its circumference or perimeter. To find circumference, we use pi d, d denoted diameter, or 2 pi r. Usually in the lower class, we used 2 pi r denoted radius. That is, circumference equal to pi d or 2 pi r. As per requirement, if d is given, we will use pi d. If r is given, that means radius, we will use 2 pi r. Pi value usually take 22 by 7 or 3.17. In lower class, 22 by 7. In upper class, both we use. Area of circle, that is a relation of pi and r, that is pi r square. We can write pi into radius whole square. Also, pi d by 2 whole square. This symbol known as pi. Here we discuss a circle boundary, that is in black color, which is measured by its circumference C, above discussed. Diameter D in blue, you see here, and radius R in red. Its center O is in gray. Next, semicircle. As you know, a semicircle is a one-dimensional locus of points that forms half of a circle. The full arc of a semicircle always measures 180 degrees. It has only one line of symmetry. In other words, a semicircle is a half of circle. As shown above, any diameter of a circle cuts into two equal semicircles. Area of semicircle, you know very well. You are familiar about that. Half of area of circle. It also write as like area of semicircle half into pi r square. It can be written as pi r square by 2. This relations is very important, play role in our life during study, mathematics, physics, whatever that. Now, perimeter or circumference of semicircle. That relation, pi into r plus 2r or pi r plus d, where r equal to radius or d equal to diameter. Now next, ring or circular path, that is shaded region. Here I have taken r for outer radius, means outer circle, small r for inner radius of small circle, you can say. Area of ring, or we can say that circular path, area of circular path, or area of an annulus. Here, pi capital R square minus pi small r square. Take the pi common, in bracket r square minus small r square. Use the identity a square minus b square. we split it as like, okay. Perimeter of outer ring we find by apply 2 pi capital R as we taken above. Perimeter of inner ring 2 pi R small r, right? Next, area of sectors and segment of a circle. Three figure here. In first figure, left side, major circle, major sector, minor sector. Sector formed by two radius, as you see here, right? Segment formed by chord, right? Major segment, minor segment, right? And third also is an arc. These three circles telling something to us here. When degree measures of the angle at the center is 360 degree. Area of the sector we take pi r square, right? It is also a area of circle pi r square. So when the degree measure of the angle at center is 1, area of the sector pi r square by 60 degree, right? Therefore, when the degree measures of angle at the center is theta, it is denoted by theta. Area of the sector pi r square by 360 degree into theta. It can be written as like. Thus, here a relation, thus we obtain the following relation, or we can say that formula for area of sector of a circle. That means area of the sector of angle theta equal to theta by 360 into pi r square, where r is the radius of the circle and theta the angle of the sector in degrees, right? Next, this figure, length of an arc AB, here is a AB, equal to 2 pi r theta by 360 degree, or we can write pi r theta by 180 degree by cancellation to cancel 360 degree by 180 degree, right? Now next, area of sector, what relation over there? You can see here OACBO is the sector equal to pi r square theta by 360 degree, right? Where O indicate the center of the circle. Above we have discussed. R is the radius, theta angle of the sector, L length of an arc, right? Here is indicated, and you can understand easily this one. Or we can write area of sector OACBO, right? Respect to L, that half into RL, where R hold 2 pi r bracket start theta by 360 degree bracket close. L, right? This one. L holds 2 pi r bracket start theta by 360 degree bracket close. Right? Area of sector. It's very important facts which use mostly in upper classes. How to find the perimeter of sector, right? Here is the figure, right? This is your figure. Sector we call as OACBO, length of arc AB plus 2r. That means above from pi r theta by 180 degree plus 2r we get the perimeter of sector, right? Now, the next about segment, right? Segment or chord, you can say. Area of segment here, theta equal to angle of sector, r is the radius of the circle, AB is the chord here, ACB arc of the circle, ACB arc of the circle, right? Here is shown. Area of minor segment, ACB or ACBA, that means area of sector OACBO minus area of triangle OAB, right? And take the relation from above, we get this one. R square bracket start pi theta by 360 degree minus sin theta by 2. That means pi r square theta by 360 degree minus half r square sin theta, right? This is the relation. As like we can find the minor segment area. Next, major segment. As like you can put the relation. Area of major segment BDAB. Yes, area of the circle minus area of the minor segment as above we have written here, right? So pi r square minus pi r square theta by 360 degree minus half r square sin theta. Here this one, okay? So this is the relation. It's play important role when you are doing the sum related to this chapter. Perimeter of segment, that is 2r pi theta by 360 degree plus sin theta by 2, right? This is very helpful to you, dear learners, right? Next, dear learners, in the end of session, I would like to tell a thought, that is, sometimes you just need to forget what is gone, appreciate what still remains, and look forward to what's coming next. In today's session, so much, my dear learners. See you again in the next session, right? Thank you, all of you.